So good morning. My name is David Bernholdt, and I'm from Oak Ridge National Lab. And I just wanted to start with a bit of introduction to flesh out one of the things that Anshu pointed out in her introductory talk. So I started out in scientific research about 30 years ago now. I started out as a quantum chemist. That's where all my formal training and my postdoc are. And so I was always very attracted to the big machines, and doing a lot of code development and things like that. That was very interesting to me. And I was the person in my group who tried, without success, to convince my colleagues to start using version control and things like that when I was a grad student. And then later on, as a postdoc, I was one of the original developers and designers of NWChem, which is a large parallel computational chemistry package, which actually still exists, and I'm told there's still some of my code in it, which is very, very scary. And then after I got out in the wild for a little while for various reasons that I can talk about over a beer, I switched my research program to computer science, but still with an emphasis on software development. So I consider my research area now to be essentially how do we support the programming of high-performance scientific applications better, right? And for me, that involves programming languages and domain-specific languages, and also a lot of software engineering. Because what I found over time is that there is a heck of a lot that you can do that doesn't require fancy tools and things like that, that is extremely valuable to doing a better job. So Anshu talked about best practices, and most of what I'm going to talk about in the next actually series of talks that you have to live with me through are those kinds of things. They're less about the tools, more about practices that can be useful. And oftentimes these things are very simple, but they're powerful, okay? So I encourage you to think about these things and not just dismiss them because, oh, that sounds really lame and not interesting. So let's give it a thought as we go through this. I want to acknowledge the funding from the Exascale Computing Project for this work, and earlier versions of some of the stuff that we learned were supported by the other parts of the Department of Energy as well. And so what I want to cover in this presentation is a little bit about how to help teams work together. Okay, so we'll talk first about small teams because that's where really most of us work. Okay, and we'll talk about a little bit about Agile workflow, different from the Git workflows. This is more of how to manage a project with a certain level of agility, and we'll talk a little bit about capital A Agile versus sort of little a Agile. And then I'm going to have a hands-on example of just how you can use GitHub to do some project management stuff. And this will be optional, but this will be part of this presentation. We'll go through it quickly, but we can also come back and do this in the evening if people are interested. So let me start with talking about small teams. So here's a typical composition of a team, especially for a university research group. You've got some senior staff and or faculty members, and you've got some junior staff, postdocs, and students, right? And the senior staff are they're the stable presence. They're sort of in charge of the scientific questions. What numerical experiments are you likely to be doing? They know the field well, they know the conceptual models, but it's probably been a long time since they've written code. And as my graduate advisor used to say, you know, his students prevent him from getting anywhere near the code as a matter of self-defense, right? And it was very true. And then you have the junior staff and students, and these folks are more transient, right? There's kind of two focuses here. You've got to get some scientific results. You're trying to get your PhD, or you're trying to get some papers out for your postdoc, and you're trying to prepare yourself for your next position. And okay, you've got some stuff to do, but you've also got to be thinking ahead, right? And this is, because this is transient, the staging is more evident to people, right? So first of all, you join a group, you're new, you've got a whole bunch of stuff to learn, and then later on, after a while, you find that you're the most experienced person around and everybody's coming to you to ask questions. And then finally, you find your job and your next job, and you're departing, and you've got to figure out everybody else in the project has to figure out what's next and what happens to all of your contributions, right? And during these times, you're learning a lot of the conceptual models in your field, and you're writing a lot of code, and you know a lot of details about that code. So let me figure out a little bit about you guys. How many of you are all graduate students? How many of you joined a group within the last year or two? And how many are more senior? Okay. How many of you are postdocs? All right. And how many of you are junior staff members or some kind of permanent position? Few people. And how many consider yourselves to be the part of the senior staff or faculty or something like that? Yeah. John's been around for a long time, maybe about as long as I have. All right. And so, we've got people who, a lot of whom fall into this kind of category, right? And so, but there's a lot of us too who are involved in large teams, right? And oftentimes what we observe is that large teams are composed of groups of smaller teams, right? You interact with a smaller group of people on something that you're working on directly, and then that's a piece of a bigger puzzle, right? And you may interact more loosely with those other people. And for different aspects of the project, sometimes there's overlapping small teams, right? Those kind of things happen too. But a lot of it comes back to the same kind of small team dynamics. So I want to argue that this model that we want to put out is effective even if you're in larger environments. Now, there are additional challenges in the interactions, and the larger the team gets, the more important some of the standardization processes, setting up policies, having regular sort of cultural exchanges or technological exchanges are important. And I'll give you an example from a couple of my projects. I have a project that has probably about 30 contributors on it, and it intentionally spans material science, nuclear engineering, computer science, and applied math. And we get together every couple of weeks on a telecon, and we try to have a presentation on progress from the computer science applied math side and from the molecular science, material science, and nuclear engineering side every time. And we kind of go through the group of people to get more people engaged and informed about what's going on in the larger team. But let's go back to the small teams for a second. What are some of the challenges that we face? Well, when you're starting out, you need to get into the team, you need to understand the background, you need to start learning the conceptual models, you need to figure out the tools and how the group operates. That's software practices, that's collaboration tools, and things like that, right? And then you're working along for a while and it's time to move on. Well, so these most experienced people from the project, if you're involved in the project rather than the guy leaving, you might want to be worried a little bit about how you're going to capture that person's knowledge and retain it within your project while they're moving on, right? So they're going to have a focus of getting away and not worrying about all this crappy code they left behind and things like that. And you might have an interest in figuring out what it is they know about the code and the software package you've all been working on that nobody else knows, and how to get that code so that somebody else can maintain it and things like that, right? And so there's this kind of dual focus that you have to manage while somebody's on their way out. So there's kind of a life cycle to this, and this is not the life or death of an individual, but this is how the cycle of research activities typically goes. So you start with this initiation, you figure out what you're going to be doing in the project. And one thing that can help you, and I'll go into a little more detail on this as we go along, is to create an initiation checklist. So checklists are really useful tools to help manage information and to get things out of your head so that everybody else can see and know what's going on. You get people started and you start ramping them up, and there's probably some more things that they need to do. They start working on the project, and then in most projects that we do in scientific research, there's typically a kind of, we don't follow a waterfall model where you design and then you go and implement and then you're done, right? We're continually revising and updating and modifying our plans, and we'll talk in a few minutes about Kanban as a way of managing that. And we, at this point, when we're sort of working, we want to have policies in place that help govern our work so that we have agreements about the way that things should be done among the team members. Okay, and then somebody decides they're going to leave, and you want to figure out what is it they need to finish up before you can let them leave. Create, well, yeah, you can stand in the way of the door, right? Not hold the going away party. I don't know what you do exactly. On the other hand, in my wife's research group, there was a guy who's like a permanent graduate student, and they held however many going away parties because he would have a job offer or something like that. And then and they'd hold a party for him, and then he wouldn't end up actually going to the job. He would just stay there. And he never did graduate. But anyway, that's not the model that you necessarily want to follow. You want to figure out what it is that you need these guys to do before they depart. Create a checklist to help ensure that you're getting everything you need. Work with them as they ramp down to figure out what they know, and they're getting off of the project activities and handing them over to somebody else. And hopefully by the time they're out, all the work that they specifically needed to do is completed or has been transferred, and people have figured out how you're going to sustain the code contributions and other things that they had for the project. And then somebody else comes in and the whole thing starts over again, right? So does this model sound familiar to people? You've probably kind of seen some of this before, hopefully. Anybody who thinks this is bogus, doesn't happen this way? Okay. So, as I said, I find checklists and policies to be really useful tools. They sound simple, okay, but they do a couple things for you. First of all, they get things out of your head and put them down in a form that everybody can look at, everybody can contribute to, and everybody can have a hand in improving and making sure they get used and executed, right? So if you're a new team member, you might have a checklist for onboarding those people. In the steady phase of the project might want to set some policies that everybody is expected to observe. And then for a departing member, you might want to have another checklist to go through. And I'll tell you, this ties in with what Jared was just talking about. Policies and checklists are a way of reducing complexity, right? Because the more things that are in your head about the way things should work and not written down and not discussed and not agreed with the team, then the more complexity you're introducing into the project. So you want to get these things out there, right? So Mike Carew, who developed this presentation, is one of the leaders of the Trilinos project, which you may be familiar with. We may have heard a little bit about on Monday. And they have a checklist for new developers to get them on board. And then a related project that you also probably heard about on Monday is the XSDK. And they have a set of policies that they want everybody to adhere to be full participants in their communities. These are laid out in terms of agreements. They get discussed. I've participated in some of the policy discussions here. And I'll tell you, there's a lot of other contexts, right? I have, in the project that I talked about a minute ago, I manage the collaboration infrastructure. So we have a wiki, we have a mailing list, we have code repositories, we have access to computing resources at several facilities, right? So I maintain information about a lot of that stuff on our wiki, and I have an onboarding page on the wiki. It says, if you're a new member of the project, here are the 6 steps that you need to follow to get yourself access to all these resources, right? And it's nice because I can just point people there. I don't have to go find the stupid email that lists all these things. I can say, go do these things. And I've got it set up so that all the information that they need is accessible to them. What I also find is that a lot of people don't do this. They'll do step 1 and then they won't do anything else. But in this case, I can leave it to their boss to badger them to do the rest of the stuff because, at some level, it's not my problem if they don't join the mailing list and, don't join the telecons. Their boss will know about that and will hold them up. But if you're the manager of a project, you might want to be more concerned about these things. So you guys have been through these experiences. You've been recently a new member in a research group, or you've left a research group and moved into a postdoc or things like that. What are some of the things that you would want to put on, say, an onboarding checklist, right? What are some of the things from your experiences that you might want to have? Okay, yeah, how do I set up my software environment to contribute effectively to the team's work? What else? Right, yeah, some documentation for the code, how to build it, what are the rules for contributing to the code base, things like that. What else? That's right. Which servers are we using? What do we do with them, right? How to get accounts on them? Who manages them? Who do you go to when you have trouble? Things like that, right? What about when you're leaving a project? So at least some of you have left a project and moved on, or have seen that happen, maybe with others, with senior students or something. What would you want to know and make sure you capture from those people? What would you want to have on their checklist? That's right, and maybe it's time to review their code contributions and see if somebody else can actually figure out what they're doing, right? Maybe you want to get some kind of brain dump from them about what it is that they've been doing, right? What else? Anything else? Right, yeah, branches that are sitting around. Well, is this thing still live, or is it? Do we need to not worry about it and we can get rid of it? So there's a lot of things that you could put on a checklist, and you can look at the examples that we had before, and there's probably a lot of other checklists out there. And once again, this is really simple stuff, but the point is to get it down, get it out of your head, and get it down on paper somewhere so that somebody else can follow it, right? I do this in my own group. I'm a manager of a group of about 30 people, and I have lists. Then when somebody comes in, so the lab has lists when somebody starts, the things that they need to do. I have an additional list for what do you need to do in my group, right? And then the lab has lists for when people leave the lab, what do they have to do? And I have an additional list, what else do I want to do to make sure we capture their work? I want to get a good backup of all their data and software and things like that, right? There's a bunch of other things that we need to do. All right. So now I want to switch gears a little bit, move from team dynamics to how do you actually manage a project. And this is, I use the term project loosely here, right? We can cover a lot of ground with this, as you'll see, okay? And what we're going to talk about here is a method called Kanban, and I'll introduce you to it as we go along. Now, probably a lot of you have heard of different project management methodologies. How many of you have heard of Agile methodologies? How many of you have heard of Scrum, Waterfall? That's old-fashioned, you shouldn't know that. So how many of you actually practice any of those things in your project? Do you have in your projects formal project management processes that you use? Anybody? So tell me a little bit about what you do.
Well, this is something we just started in our organization, and we pulled together, let's say, four people, and then focus on one single thing within 3-4 weeks.
Mm-hmm.
We have a product owner, we have a Scrum Master, and we have developers, and yeah, we do it.
Okay.
And we're still experimenting with it. I just actually got out of Scrum before I came here for training.
Okay.
It was an interesting experience.
They let you loose, huh?
But just to be clear, we're actually not developing software. We use the concept for something else.
And that's a very good point, right? And I'm treating this more from a project management perspective. These same approaches can apply to managing software development, and I'll show you how you can use some of the tools that you're familiar with from software development to actually do this from a project management standpoint. So it goes kind of back and forth, but it doesn't have to be just software development. Anybody else using any of these sort of named software development practices? Yeah, Christy?
Well, I mean, I had an internship where we would meet up for like gotta say, it's more productive when the other people who are meeting up with you, like, are actually serious about meeting up.
Yeah. Yeah, I've encountered that. You have a meeting with your team, and okay, what have you done this week? You go around the room, and everybody says, nothing. Right? Yeah. Okay. Yeah, maybe not so cool. All right, so let's talk about this a little bit more. So how many of you are familiar with issue tracking or bug tracking for software development? Okay, fair few. How many of you actually use it in a project? Okay. So there's various ways that you can do this. Basically, the idea behind here is, once again, to collect information about what's going on in your software development in this case, and make it available for everybody on the team to see and make use of, right? So how could you do this? Well, a lot of people are just keeping these things in their short-term memory or on a notepad in their office. That doesn't get it out there for everybody on the team to see, right? You have to remember, you have to talk about it at the next team meeting and things like that, right? Well, you could write it down. That would be a good step, but it still doesn't share it very well. You could put just a text file in the root of your code repository that lists the issues that you know are in play and somebody should deal with at some point in time. That starts to share the information with everybody, right? Well, you can take that further, right? You can put it out into your software repository system itself. It may have tools like GitHub issues, right? Or something like that. Or you can use a separate bug tracking tool like Jira or something else, right? And then you can you can sort of take this all the way, and you can think about it not just for managing the bugs or the defects in your software, but you can also think about it as a tool, same processes, same tool, to plan your development, right? What is the next thing that we want to take on, right? What are the new development areas we want to pursue? And you can use issues to plan those out. Okay, here's what I want to do. You can have some discussion, just like you can have discussion of somebody tracking a bug and tracking it down and figuring out how to solve it. Okay, well, here's what I think about this. Oh, I think that's a stupid idea. No, I think that's a really brilliant idea. Here's how we would go about it. Okay, let's assign it to Julian, right? And so you can do managing the software development in these same kind of tools, right? And you can also take away the software part and just do some project management stuff with these same kind of tools, right? It doesn't have to be a software project per se that you're planning or managing, and it doesn't have to be issues for software. It just has to be things that you need to think about effectively. So we'll talk a little bit about Kanban and Scrum. So Kanban is kind of a simplified Agile methodology, and I think general experience has shown it's much simplified over something like Scrum, and I think many people find that it works well with typical scientific software development, where it's hard to come by really well-defined work, and the work doesn't naturally go in a 2-week or a 4-week Scrum cycle or something like that, right? And so we'll talk a little bit about Kanban. The most important principle and what is the distinguishing feature of Kanban is this idea of limiting the number of work-in-progress tasks, okay? And this will make more sense in a minute. But the basic idea is that everybody involved in contributing to a software base or just working on a project, in your own work, in your own life, there's only a limited number of things that you can successfully juggle at a time, right? This idea of multitasking has been widely debunked. And most people, if they are supposed to be working on 10 different things, they're probably spending more time doing context switches between those 10 things than they are working on making progress on any one of them, right? So the idea of limiting the number of tasks that you take on at any given moment is important. But then when you're not doing all those 10 things, you need to have a way of keeping track to say, oh, as soon as I get this one done, here's the next thing that I need to worry about, right? And here's this backlog of stuff, right? And so the idea here is a very loose process that doesn't say, okay, 2 weeks from now on Tuesday, I'm going to have a brilliant idea, and then we're going to implement it in the next work cycle, right? It allows a lot more flexibility, and it allows you to understand what your productivity is and what your team's productivity is, okay? And manage to that and focus on that, okay? And the way this is implemented is with a board, a Kanban board, that often looks like this, okay? Basically a series of columns. This actually started out as sticky notes on a whiteboard, and you can do it with something that simple. You don't really need fancy tools. You don't need to have a web tool or something like that to do that. If your team is all co-located and they can all see the whiteboard in the conference room or whatever, this could be a really good way to do it, right? So you put a sticky note up, excuse me, for each of the tasks that you think need to be done, any kind of idea, right? This is your backlog. These are the things that you pull later from what you want to work on. So anything can kind of go in here. And then at some point, you understand, you've thought about something well enough, or it becomes important enough that you know you need to address it soon. You understand how to do it, you know the scope of the problem, you know how you would solve it. So you take it from the backlog and you move it to ready. This means I'm ready to work on this, or the project is ready to work on this whenever somebody has free cycles to do it. And then there's this idea of tasks that are in progress. We limit the number of tasks in progress based on the essentially the mental bandwidth that we have and our experience. But when a slot opens up for work in progress, let's say we can have 3 things in progress, right? So you get one done and you move it to the done category, right? And then you have a slot open here, so you pull something from the ready pile that works for you in various ways, and you start working on it, okay? And the process of managing the work, whether it's software development or any other aspect of a project, is simply this process of tracking things as they go across this board, right? And at the end, you get this really nice list of things that you've done, which is really nice when it comes to do your performance evaluation at the end of the year, or when you have to write a report for a sponsor or things like that to remember a lot of the stuff that you've done. And we'll talk a little bit more about managing the work in progress here. You can be flexible about these and how you implement them. Okay, these columns, I'm sorry. You can add other columns. You can experiment with this a little bit. So another common column in many cases is some kind of in review, right? So if you're producing things and somebody needs to check the work to make sure it's okay, or if you want to have, if you use code reviews to contribute, to gate contributions to your software repository, you might want to have an in review column. So something gets done from the in progress column, it doesn't go immediately into done, it goes into in review. You would have an in review column here, and that says, okay, now a reviewer can look at this and double check, and then when they sign off, whatever the policies for your project say, then it gets moved into done, okay? You can also, if you're a little bit bold, you could have a version of the in review column if your student says waiting on advisor, right? That could even work for a postdoc. So, you know, that's a little bit bold, but it helps keep track of, you know, things that you might be waiting on from others. And your advisor is a particularly important person that you might want to wait on for some things. Mike Haru, when he gives this talk, also mentions that he does this personally, and he has a column called Tasks I Won't Do. And so this is a reminder to himself of things that he's not even going to put in the backlog, because he should not be doing them. He's already made a decision. One of the rules he has now is he never schedules a meeting for more than 30 minutes. If it can't get done in 30 minutes, it's not worth doing, right? And so that's one of his things, just as a reminder that he doesn't want to do that. So any questions about this basic Kanban board? How many people have seen this before? A few of you, okay.
How would you acknowledge ongoing tasks? Something that would that potentially sit in the ready state, in progress state?
Well, so it depends on exactly their nature. If they're cyclical, then you get something done and then you have to redo it again, like some kind of quarterly report or something like that, right? You could automatically, even with some tools, you could have these things come back in and they get themselves scheduled, and you need to do it, and it has information, so you know that there's a deadline coming up, and you need to pull it into in progress and get it done at a certain time. There are other things that are really just ongoing, and they may not fit this model exactly. There are, in many cases, most people would treat a lot of the reporting as a background task that wouldn't get tracked in this way necessarily. Really, the best thing is to figure out what will work for your project, right? So there may be certain kinds of things that don't go on this board, but maybe you have a separate list, sort of ongoing activities, and there needs to be periodic checks on those or something, right? To make sure they're happening, or to make sure that your sponsor hasn't stopped sending you money or something like that. Any other questions? Okay, you can use this Kanban approach not just for project management, but you can also use it in your personal life, right? So you go home, you have things that you want to do with your family, you have things you need to do around your house, you have a whole bunch of other things, and you can use these same approaches to manage what you need to do there. Keep track of what you need to do. There's only a certain number of things you can accomplish at a time, right? If you're doing a renovation on the kitchen of your house, that probably crowds out a lot of other things, right, from happening. And so you can think about it in this same way. It's not saying that you have to use it, but it's something that you can think about. And I also want to say, a lot of what we've talked about here in terms of both this board and getting things into the backlog and putting them, exposing them here, and also a lot of the stuff about checklists and policies and things like that is also very consistent with a personal productivity approach called getting things done. The approach has been around for a while. Maybe you've heard of it. How many people have heard of it? Getting Things Done, David Allen. So it's a very interesting book. I do highly recommend it. But his basic premise is to capture everything you need to be thinking about and get it out of your head and onto paper. And then you can go through and systematically review it. You can prioritize it. And you don't have to spend the mental bandwidth saying, well, what was on my list of things to do? What should be my next priority? Because it all gets muddled up in your head, especially if you have a lot of things to think about. And so these processes are all very consistent. And at the end, I'll have a pointer to that book in case you're interested. This is pointer to the personal Kanban book. Now the tools, I said, you can just put sticky notes on a wall, or you can draw things on a whiteboard. You can do this with software that's available in the cloud or sometimes on a server that you can instantiate. Trello and Asana are examples of this. This approach, basically, it's a lot of flexibility. Jira can do this. You can do this with GitHub issues, which I'll show how to do in a minute. Mike likes to use Trello, and he has access to it there's a browser version, and he also has it on mobile devices. And this is true of a lot of these kind of apps nowadays. So and as I said, Mike uses this personal Kanban approach, and so he can go just on his phone and figure out what he's supposed to be doing or not supposed to be doing, and capture what's going on. So the big question here is managing this work in progress. How many tasks should you be doing as a person and as a project, right? This can be very individual. And it's something that you have to do some experimentation with, right? Oftentimes, the advice is to start with 2 or 3 and see how it goes. Sometimes people can handle more. Sometimes people can only handle one thing at a time, right? Depends on the individual. But a good analogy for this is freeway traffic, right? If there's only one car in the road, the road's not being used very effectively in many cases. There's room for a lot more in most cases. But when you start to get more flow, then the progress of individual cars along the road can get bottlenecked, right? Because there's too many things going on. You have to contend with other people. You can't get through the congestion as easily and things like that. So you want to manage, and this is the mental congestion in many cases, the context switching, things like that. So you want to think about, as you're instituting this process, are you spending too much time context switching? Right? Does everybody understand what I mean by this term, context switching? This is a term from operating systems, right? When you have one process, the CPU does really only one thing at a time, right? So if you're going to timeshare a system with multiple processes, then each process has to switch in and out. And there's an overhead to that, right? We have the same mental overhead when we stop working on one project and pick up on another, right? You have to save the state for one project and you have to load the state for the other, okay? But if you do this thoughtfully, you'll figure out where you sit on this, and you can do this with your team and figure out how many things your project team can effectively work on. And you can keep track of your board and track your progress. There are ideas about the velocity of your project, how many issues you're retiring into the done column with time and things like that. And so you can get a feel for some of these things. And a really important thing here is that it can be easy to get distracted from these processes. It can be hard. You have to really make them a habit. But if you get distracted and you find you're falling out of it and you want to get back in, it's not that hard, right? You just have to work back into it step at a time, okay? So as a junior community member, you probably have less control over your tasks. But if you can use this idea of work in progress and get some buy-in perhaps from your supervisor, you may be able to push back and say, your advisor comes to you with some new brilliant idea that he wants implemented by Wednesday. Oh wait, today's Wednesday. By Thursday. And my advisor used to do that. He would call us up and we'd say, you got results for me yet? And that most of the graduate students would not answer the phone because they knew it was him calling, asking if they'd finished the new thing yet. But if you can take an approach like this, and if you can get your supervisor to buy into it, you may be able to say, okay, I'm working on these 3 things already. Which is the most important? Which should I put aside? Right? It gives you a tool to have a conversation. That may or may not work depending on your advisor, but hopefully, at least as you go on in life, that's maybe a more likely thing as you get out of graduate school and further in. My experience, at least, is that the power dynamic is you get a little closer, and you might be able to do this more easily. So it can be a tool. So, kind of summarize. I talked about checklists. They're obvious places when you're starting up somebody, when you're making some important transition, when somebody's leaving a project. Policies, writing down how a team conducts its work. That applies not only to the policies that you want to apply to, say, your use of GET on the project, but there can be a lot of other policies that you might want to institute as well. And then using some kind of issue tracking mechanism, not only to think about the specific software development activities and to track bugs and to plan activities, but also just to think about managing projects and managing perhaps your life. Okay, and I want to say, another important related thing, I said back in the beginning that I was an original member of the NWChem software development team. So we actually spent a heck of a lot of time designing this whole software system. It's now about 4 million lines of code, right? And we had to do a lot of design. We wanted it to be scalable and sustainable and things like that. And we were doing something new, and it was really important to us to get it right. And we didn't, at the time, this was 1992, we didn't have issue tracking tools. We didn't have GitHub. We didn't have things like that. But what we did was to have our design discussions on a mailing list that was archived, right? So rather than sitting around a room and talking through all this stuff and nobody remembering what we actually said, we instituted a discipline of having these discussions on a mailing list And since we had an archive, we could go back and see what was said, and we had a record of our decisions and why we made them, right? And this can be really important from the aspect of planning work and planning new development in a software system or in a project, right? Why did you decide to do it that way? If you can go back, if you capture that information, you can go back and review it later on, and maybe you need to revisit your assumptions later on, right? There's things that caused you to make that decision. Maybe those have changed, but maybe they haven't, and maybe you want to revisit enforcing that policy which you've gone lax on, something like that. Okay, so a lot of this is about using the tools, simple tools, to get things out of your head and out on the table for the team to see and use. So this is something that Mike's done. Mike is not only a researcher at Sandia National Lab, but he also has an appointment with a small college near where he lives. And it happens to be in a place called Collegeville County. And so Mike has this Collegeville organization that he works with his students, and these are some of the policies that he uses with his students. And you can review these things if you want. You can find Mike's Collegeville site on GitHub, or you can look at these slides later. I'm not going to go through this, but here's an example of how he interacts with some of his students. And here's an initiation checklist for somebody, right? Learn LaTeX, identify new software repositories that you need, sign up and take some Udacity courses that he wants people to be familiar with, right? So here, take a C++ course, things like that. So these are examples that he's done with his students that might inspire some things for you. You can find, if you look around, you can find a lot of projects, an increasing number of projects have policies and checklists and things like that they use. Here is the Kanban board, and this is also in GitHub, and I'll show you in a minute how we can do that, actually. So we have about 15 minutes left. If people want to do a very quick hands-on example, we can do this. Yes?
Instead of having those separate, just have a pre-seeded Kanban board with someone's initiation checklist?
Yes, essentially, yes. You can essentially duplicate an issue. So you want, if you're using issue tracking, it's good to be able to tag the person who should be responsible for these things, right? And that's one of the things that's lacking in the way I do the onboarding in that project that I talked about, right? I just have this list out there, and I leave it to the person and their supervisor to do that. But if we had an issue tracker that I could say, this is your task or your list of tasks to get started, then we can all see as you check off the list, and I can look and say, you're not making enough progress, or somebody else can poke you and say, well, it would be a really good time to do this, or whatever. Okay, so yes, there's ways to deal with that. Oftentimes, if you have, the checklists may or may not be customized, right? So sometimes it's just copy and paste from one person to the next. Sometimes they need fiddling, right? But there's a lot of ways you could do that. So anybody want to do a little bit of a hands-on exercise? How many people are familiar with GitHub issues? How many people? Okay, pretty good number. How many people are familiar with GitHub projects? Not repositories, but projects that are kind of like a Kanban board. You've actually used them? Good. Yes, it's this thing. Anybody else actually tried that? Okay, a couple of people. So let's do that. Everybody, I suppose, has a GitHub account. Why don't you sign on to your GitHub account? And I'll find a browser here. Okay. So this is me. We're going to create a new repository. And you can call it whatever you want. I'm going to call it AppPesc Issues. Okay, this is... And one potential downside of GitHub for project management is sort of the default for GitHub is that repos are public. If you want to have a private repo, you probably need to give them money in one way or another. In a project management context, you may or may not always want all your stuff to be open. Okay, so that's something you have to consider. Right now, just for purposes of examples, I'm not going to worry about that, and I'm going to, oops, I can't drive looking behind me. So I'm going to create this repo with a README. I'm not going to worry about a git ignore or a license right now. Okay, everybody there? All right. One of the things that you can do, so we're going to focus on the issues, but we also have the ability to actually have code here. Maybe not code, maybe this is where we keep our policies, right? So one of the things you could do is create a policy, and we're going to call it team policy.md. How many of you are familiar with Markdown that's used in GitHub? Okay, a little bit. So it's just a simple way of marking up text to make it, to allow it to be processed a little bit more nicely. This is a site that's referred to in the slides. I'm not showing you the slides, but in the slide deck, there's step-by-step instructions to do this. And this is a site called contributorcovenant.org, and it has a suggestion for a set of practices that your team might want to implement, right? And they have it conveniently in Markdown form. And so this is the Markdown. I'm not going to go into details right now, but I'm just going to copy this thing. That was not good. I'm going to paste it in here. And I'm going to commit it, and I'm not going to worry about the messages. It's bad, I know, but there we are. So now I have a team policy, okay? And you can see how it's been pretty printed by GitHub because of this Markdown. And we can talk about how Markdown works, say, after dinner if you want. So now we have a policy for our project, but the main thing we're interested in is using GitHub to track the things that we need to do on our project. So we're going to go over to GitHub issues, and we're going to create a new issue. And let's see, this first issue is to onboard Anthony, because we're going to force Anthony to join our project. And so we're going to have a little onboarding checklist for Anthony. And so you can do these things. So let's make him learn about Git rebase from the references that Jared provided. And then we're going to ask him to do a private example of Git rebase. So he's going to create a repo of his own and do some commits and then do the rebase so he understands better how it works. And for now, this is enough to get him started because we have a very simple project here. So now you see these have little checkboxes. So I can send this, I can tag Anthony with the, as a person who needs to do this ticket, and he can check off those checkboxes, right? And so let's see if I can edit this. So the Markdown is the dash makes a list, and then the brackets with a space in between gives me the checklist box, right? So this is a nice little thing that GitHub Markdown will do for you, okay? So now if I'm not going to take the time to add Anthony to the project, but I could add Anthony to the project, and then I could assign this to him, and then we could track his progress through this, right? And let me make another new issue, and this is, so the next thing is to develop a fancy feature 42 for our code, and I can't even read that, so there we go. And this requires issue 1 to be completed because we're going to make Anthony do this one too. Now you see another trick in GitHub. There are some shortcuts this is a way of referring to other issues, right? So you can start making connections between issues. You just say the number of the issue, right? And it knows what it is to be completed, right? So we're going to submit that one, and we're going to have maybe one more test fancy feature 42. All right, maybe we're going to ask somebody else to do that. Okay, so now I have a number of issues here, and there's one I don't really care about, but I'm not going to worry. So now, so I have these issues, and I can use them as issues, right? We can track the progress there. But now I can also go to this new, relatively new feature in GitHub called projects, which is really just a way of presenting the issues differently. So I'm going to have it create a project in my repository, and I'm going to have it, this is going to be the @pesc Kanban example. And GitHub helpfully gives, well, let's see if I can get some of this on the screen. There's a couple of different ways that you can get this started. GitHub can help you, right? It can give you a basic set of Kanban columns. You can start from scratch. There's a couple of other things which I'd have to fiddle to get on the screen, right? So let's just have a basic Kanban board here, and we'll create the project. So here's the board, right? And provides some helpful information here, which we're not going to worry about. Let's see, I can scroll down here. So you see right now, there's just some informational stuff here. It's not actually, doesn't have any of our issues in it. So now I need to add cards. Cards in this, I'm sorry, come on. There we go. So a card in this sense is an issue, pulls issues from the issue list, right? So I've got, where'd my list go? That is not what I intended. Sorry, add cards. There we go. Okay. I don't know what it was showing before. So here are the issues we have, and I'm going to, just for fun, drag these over and put them in our to-do list. If we had we could add a backlog column and start there if we wanted to, but I'm not going to worry about that right now. So we have a couple of things here. And now, since Anthony's raring to go, we're going to get him in progress on onboarding those things, onboarding himself, actually. And then eventually, he's going to be done with that, right? And then maybe there should be another, oh yeah, we have to develop fancy feature 42 before we can test it, right? So let's put this here, let's put that back. Okay, so there's a state that we might be in at some point as we progress. And now the next thing up on our list is to develop the fancy feature. And then maybe when that's done, we'll have testing for it, things like that. So you can see here, it's a very simple board. You just drag and drop these things around just like you would think. Very natural kind of interface. There are some limitations. GitHub offers certain kinds of automations. You can investigate that if you want. So you can, and that has to do with how it connects. Say if you went into the issues and Anthony marked everything done, that ticket was done, then you could have it automatically move into the done column here and things like that, right? So those are kind of add-ons, but a lot of this is not the fanciest Kanban board implementation, but it's something that works. And the virtue of this is that they're simple tools. They're tools that you are probably already using or using things next to them, like the code repository, in your daily work. And so, oftentimes, as I've been saying, some of the simple tools and some of the simple concepts are the most useful things to consider, right? And this is one example. Jira can be very sophisticated, can be very complex. You can spend a lot of time setting that up if you want to, get all kinds of wonderful things out of it that you're not going to get out of a GitHub project and using issues. But GitHub's right there, right? So it's worth considering. And there's a lot of other cases like this as well. So in terms of project management and productivity for a project, as in a software development sense, in a project sense, and oftentimes in a personal sense, the fancy tools are not necessarily the most important thing that you can do. All right, any questions about this stuff?
So do you use these tools for performance review or for doing making managerial decisions as to whom to promote or not, something like that?
So personally, as a manager, I do not do that, and there are a couple of reasons for that. One is because the group that I manage is largely a bunch of independent investigators. I have some projects that I lead, but they have other projects. Sometimes they lead, sometimes they're working for somebody else who's not in the group, right? So for each of those projects, they're getting things done, and they're not necessarily, there's not necessarily any cohesive way that I'm doing things interacting with them in a way that would make this make sense, okay? But within my group, we're also incubating a team of research software engineers. Anybody familiar with that concept? So this is kind of a different career track that's developing, started in the UK and over the last 10 years has become fairly commonplace. This is the idea that some people, especially PhD level people, will go out and they'll decide that they're more interested perhaps in the software development side of things than they are in the research side of things. They're a lot less interested in writing papers, chasing money and writing proposals and things like that. They'd really much rather sit down and work on code, right? Maybe that's what makes them happy. And so oftentimes these people kind of end up in obscure side positions that don't get recognized very well, like a permanent postdoc or something like that. And so there was this attempt in the UK to develop a new track called Research Software Engineering as a career track. And they've really fleshed that out there very well, and it's starting to expand worldwide. So we're creating a research software engineering group within a team within my group to help O&L researchers do a better job with their software development, help give them better software practices, help support their development so that the code they produced, if they wanted to, was maybe more than research quality code, getting closer to production quality code that we might be happy putting out in public and having people use maybe for a long, long time, right? Some of the numerical libraries that you've heard about in this would be a good example of code that can live for a long, long time that you might want to invest some higher quality practices into, right? So anyway, so research software engineering, Jay, the guy who leads this team, actually does have, he kind of has his own, not exactly a Kanban board, but he does use similar tickets. He has a private repository that he actually opens to his managers, which is me and my manager. And then he expects his own direct reports to do similar things. And he keeps track of what he's working on, what he's done, and go through it. Not Kanban, but using GitHub issue tracker, literally. All right? Other questions, other comments? How does this coincide with some of your experiences? Do you see anything useful here? See anything that sounds completely ludicrous? Because everybody there are a lot of different experiences. One size does not fit all. It's a lot about adapting to what will work for you and your teams. But, you know, there's a lot of useful things out there to try to work from. Yeah.
Ask a slightly different question. Since you mentioned NWCam a couple of times, I hear the word often about the software package. So
Yeah.
The time NWCam was developed, you guys did it in Fortran 77, and MPI RMA was not there, so you wrote global arrays and ANSI. So what I'm asking is that you talked about designing an NWCam, but the tools that you had at that time, they were not sufficient. I mean, you had to work on a kind of a strict, rigid system.
Yes.
So how did you do the design, or how did you find this design process?
Yeah. So that's a very interesting question, actually. So we can talk about it more offline, but I'll just give you a short answer for now. So there were so we did spend a lot of time on design. I've never been on any other project that spent as much upfront time on software architecture and design as we did on that project. So we had a number of considerations. We wanted to do the project in C++, but in 1992, C++ was in a very different state than it was now. Implementations were not at the performance levels they have now. Compilers did not have the reliability and robustness that they do now. And also, in the chemistry community, nobody was learning C++. So we decided that we couldn't afford to just dive into C++ because we wanted people to be able to onboard to the project and make contributions quickly. And if they had to learn a whole new language, that wasn't going to help, right? So we decided we didn't have an alternative but to use Fortran. And, but we did that with as much object-oriented style as we could put in there, right, into the design. So we had to do a lot of that manually, and that gets to another point. There's another thing about this whole productivity thing, and it also applies to software development in general. Discipline goes a long way. So we designed these things. We did OO programming in Fortran without any object-oriented features, and we made everybody design that way who was involved in the initial team. And it's worked really well, right? And those kind of concepts still work, and it gives us a flexibility in that package that is still hard to get in other quantum chemistry packages because of this OO design. Now you would do things in C++ and it would be completely natural. And if we had to do it over, in fact, there's an NWChem exascale project where they are doing it all over in C++, right? So global arrays was the other thing you talked about. So global arrays, for those who don't know, is a partition global address space model, programming model. It's implemented as a library. So we were thinking at the time about how to do Hartree-Fock, and a lot of other people in chemistry were thinking about the same thing, right? And people had done this. It's a very complex algorithm because it's a 4-index tensor contraction. And so contributions come from all over these symmetric matrices and stuff like that with strange symmetry properties. And to do it efficiently, you have to take advantage of all of them. And coding that in MPI, getting all the pieces of the distributed data to the right place at the right time was a mess. Somebody at Buffalo actually did it and basically said this was not sustainable, and we realized that they were completely correct. So we realized we had to come up with an alternative programming model. We knew what we wanted. We wanted this partition global address space, so we wanted to just be able to say, put this, get this, and have everything work. And then we spent some time prototyping the features that we really wanted, what was critical and what wasn't, and then we sat down and developed it. And that's how it happened, and that too has been around for 20 plus years. And it's still used.
I looked down for a moment and I didn't see how you actually added the Kanban. So is this something that can be added to an existing GitHub repository? Is this
It is. It's this projects tab. It's not well named. But if you go to an existing GitHub project, so this was introduced maybe a year ago, okay? And so that's what it is. That's all you have to do. All right, last questions before we move on to the next topic? All right. So, and I will be around this evening and stuff, and if you want to talk more about any of this stuff. So now we're going to move on to something that's quite different.